Hello, math analysis student. It's Mrs. Lara. Hopefully by the time you watch this, you have at least seen the 3 videos that are linked in Google Classroom for week 14. They are Khan Academy videos that I really liked, and you could have attempted this assignment or not. It is in my math lab, okay? But my hope is that my walking you through will help. All right, so I'm going to distinguish first the difference between limits and f of x. So those are 2 very different things. We have been doing f of x since, unit 1. So since in the notation it says x approaches 0, we care about 0. Now f of 0, sorry for the sloppy writing, is 0. And I can tell because that's where the solid dot is, okay? Down at the bottom over here, you can see it's actually not touching, it's just going down. It looks like an asymptote on the left. So f of 0 is 0. That's not what we're asking. That's old news. We are asking, what is the limit? So now the limit as f of x, as x approaches 0 of f of x, what you are asking yourself is you are saying, as I get closer on the left to 0, and as I get closer to the right of 0, what number are we approaching? Is it approaching the same number? If it is, then most likely the limit exists. But if they are not approaching the same number, the limit does not exist. Now, looking at this, it does not exist. The limit does not exist because on the left side and the right side, the graphs do not meet, okay? That's one way to think about it. But as we go to 0 on the left, it actually goes down and keeps going down towards negative infinity. To approach it from the right, you would have to come from this parabola portion and you would get to 0. Since those two do not agree, they are not the same, it does not exist. There we go. All right, number 2. Number 2, actually, I'm going to do number 3 first and then come back to number 2. And hopefully that makes sense in a sec. So for number 3, we are asking, what's the limit as x approaches negative 3? Now, again, f of negative 3 is something different. F of negative 3, when we go to negative 3, we go down. It is an open circle. It is undefined. I've got to get this writing better. Sorry about that, guys. But that does not mean the limit does not exist. What we're asking is on the left and on the right, as we get closer to 3 that way and that way, again, we will ride the graph to get there. But as we get closer, do they go towards the same number? So let's see. On the left, get that out of there. On the left, you'd come down like this. There we go. Come down like this. And it looks like that is going to negative 2. Now on the right, as I go down, I'm not to negative 3. Remember, I'm going towards the x equals negative 3. There it is. And it is the same number. It is negative 2. So the limit was actually something different. So the limit, it does exist, and it is negative 2. I think that helps number 2 just a bit. It says, tell whether this statement is true or false. The limit as x approaches 3 of f of x equals 4. Then 3 must be in the domain. That means 3 must be defined. Well, from example 3, we know that's not true. At negative 3, there was no value, but the limit still existed. And so I know it has to be false, so that means these 2 can't be true. So is it false because as the x assumes values closer and closer, but not equal, or B, perhaps equal? Well, it cannot be equal. If it were perhaps equal, then it could be in the domain. Okay? There we go. Number 4, decide from the graph whether each limit exists. If a limit exists, find its value and do not use a calculator. All right, so again, what's happening as x is getting closer to 4? So 4 is right here, so we're going to go closer on the left and closer on the right. But I'm going to ride the graph. That's just the x part, so let's see. From the left, I'm getting -2. From the right, I'm getting -2. Now, is that f of x? And the answer is no, it is not. When we say, what is f of 4? It is actually 3, right? That is this dot up here. That is f of x. But when we're asking for the limit is -2. I'm hoping that is a distinction between the actual value of f of x, that's that dot, and the limit is getting closer and closer and closer to difference. Okay, so the answer is the limit does exist, and it's going to be -2. All right. Now we also need to, wait, did I answer 5? I did not answer 5. Sorry about that. So this would be a good time, I think, for you to pause and check and see if you got it, and then unpause when you've got an answer. So determine from the graph, decide from whether the limit exists. If it exists, find its value. So we're getting closer and closer. Now, first of all, let me find f of 2, right? I'm trying to distinguish. Oops. F of 2 equals 0. That's not what they're asking. They're asking what's the limit. So the limit of f of 2 on the left, it looks like there's an asymptote. It actually goes up towards infinity. That's from the left. From the right, the closer we get to 2, is 0. Those do not agree, so the limit does not exist. Okay, and I'm just double checking and crossing off the problems I've done. Let's go to number 6. Wait, where's number 6? Sorry about that. Number 6. Number 6, they give us a table. And so we don't even know what the definition of this function is, but they are asking us getting closer and closer to 8. 8 would be in here, right? And just like the graph, on the left, as we get closer to 8, now again, not touching 8, we don't care about the actual value at 8. Are they getting closer to the same value? On the left, it's getting closer to -6. On the right, it's also getting closer to -6. This is -6. Okay. Number 7. Number 7. Now, here they gave us a table, a blank one, and they're asking us to create it, fill it in, rounding to 4 decimal places. So what I'm going to encourage you to do is in a new window somewhere, open up a Desmos tab. You have to do the Desmos calculating and the tabling all at the same time. It is a skill. So here is what I got when I put it in Desmos. So I typed in -2x cubed, and then I clicked, remember to get the table, you click this grinding gear kind of thing, and then push the table, and then I just inputted the values that they gave me in the problem. So when I put those values in, here's the y's that they gave me, and they said to round to 4 decimal places. So to 4 decimal places, this one would stay the same, right? 5418. You would get rid of the 0.02. This would be 0540, and you'd forget about the 18. This one would be the entire thing, because that is 4 decimals. Here you'd have 1, 2, 3, 4. 1/8 does not round it up. And here, all right, finally we have a change. That 9 makes that 7 and 8 at the end. Okay, so I'm going to go back to my slide and enter these values. Sorry for the back and forth. So, this was 54. Oops. $54.5418. This one was 54.05. Sorry, my stylus is not cooperating with me. 40. This one is 54.0054. 53.9946. 53. 9460. And 53.4618. All right. We're asking what's the limit as it approaches -3. Well, -3 would be, oops, -3 would be right in here. Again, we don't care what it actually is at -3. What we care about is on the left, what number is it getting closer to? It looks like 54. And on the right, what number is it getting closer to? It looks like 54. So in the answers, it says type an integer or a decimal. We want a 54. It's a whole number. Okay. Now, for the next one, this is the screen I used. For number 8, I actually figured out how to put the Desmos below. So what I'm going to ask you to do right now is pause and type in absolute value of 3x minus 4, make a table. And then the values, this time notice they didn't give us a table, so I had to come up with my own tables. Well, I like thinking about a number line, so I'm going to draw a number line for those of you that are having trouble. So let's put 0 right here. Let's put 1 and let's put 2. Okay, so what we're asking is put numbers on the left and put numbers on the right. The furthest left that I'm going to use from point, and remember we want to get right here. This is where we're trying to get. Okay, the furthest left I'm going to go is -0. No negative. Sorry. This is +1. I'm not going to use any negatives over here. I'm going to say 0.9. 0.9 would be really, really close, but 0.99 is even closer, and 0.999 is closer still. So this is how I came up with my values. Okay. On the other side, 1.1 is going to be as far away as I go. And if I insert some zeros, that actually makes me a little closer. Boy, I don't like this graph at all. Let me do it again. Okay. So 0, 1, 2. So 0.9, I'm going to put it right here. But 0.99 would be closer. and 0.999. I'm just seeing if this helps give you a visual. I've had students who have trouble coming up with values for a table. Now on the right side, the furthest I'm going to go is a tenth away, which would be 1.1. To get closer, put a 0 in. To get closer yet, throw another 0. There you go. Hopefully that helps, okay? And then I have my table. Okay, I'm gonna, oh, I don't see my table anymore. Sorry, I had to put the table back in. I don't know, I must have accidentally deleted. I didn't even see that I did that. So here we go. Once you have figured out your values, create a table and then put them in. It doesn't ask us to record our values here, so that's nice. Remember, the limit as x approaches 1, 1 would be right here. So look at the y values. As they get closer here, we're getting closer to 1. As we go up, or from the right, still getting closer to 1. So my answer, there is a limit. Oops, I wanted to do that in black. And my answer is 1. Number 9, make sure I don't lose my graph here, my table. They give you the table, so just type that into Desmos. Don't skip this step. It's so important that you can do this for the test. You will have to open a Desmos browser. You can use a graphing calculator or something like that, but it's a little trickier. Desmos does allow you to make sure that your function is exactly correct. In a graphing calculator, you're never quite sure if it is or if it isn't. So that's just a little thing to consider. But you can make a table in a calculator, a graphing calculator as well. And if we were in class, I would go over that. But for now, we all have access to text, so let's just use Desmos. When we look here, this one actually wants it rounded to 7 decimal places. So when I look at these values, 7 decimal places, 1, 2, 3, 4, 5, 6, 7. So that is going to change this. The 7 is going to change that last number to a 2. That one does not change it. The 3s are not powerful enough to change. But then again, this 7 does change that to a 2. All right, and now let's record our answers in our table. So that is 0.998. I don't know who thought 7 decimal places was necessary. That was not me. 9983342. And then 999. 8. Oh, one more 9. And then 8, 3, 3. Make sure I got the right number of decimal places. My math lab is very picky, and if you don't get the right decimal place, it will mark it incorrect. 6 9s and an 8. And then the last one is the same as our first one, where, whoops, there's 2 like this. There's 2. There. And finally, the one where we needed to round again, 0.9. 3, 4, 2. That's 7. Turn that 1 into a 2. So my question is, as x approaches 0, so 0 would be right in here. Are we approaching the same value on the left and the right? And the answer, in my opinion, is yes. They're both approaching 1. So number 10, again, pause the video, go to Desmos, type in the function, make a table. Now, negative 4 is our value, so I'm going to put negative 4 here. So that means negative 3 would be on one side and negative 5 would be on the other side. A tenth away would be negative 4.1. But if you want to get closer, throw a 0 in there. And if you want to get closer still, 0, 1. And then on the right side, negative 3.9 would be a tenth away. I almost said 4.1, but it would be negative 3.9. Again, if you want to get closer, throw in another 9. You don't need to draw out this number line. This is to help visualize what numbers should go in your table. Okay? And I think everybody, when you look at this, yes, it's getting closer and closer to negative 4, the closer I'm getting on the number line. Okay, so those values should be what I inputted in my table. Notice I put in negative 4, but it is undefined. And so when I look, negative 4 is right here. When we go this way, the value that we're getting is about negative 20,000, right? But when I come up